students, welcome to Phidel Virtual School. Today we'll be having mathematics at senior level, and the topic we'll be looking at is simultaneous equations. Okay, and we'll be looking at simultaneous equations involving linear and quadratic equations. This is a very important topic at senior level, and that is why it's important for you to be able to solve any questions given involving simultaneous equations. So if you're ready, let's start. Now, today we're going over a couple of examples, and for today actually we'll concentrate on solving simultaneous equations using algebraic methods. And the two methods we're going to be looking at today are the substitution method and the elimination method. Okay? But for today's lesson precisely, due to time, we'll only concentrate on substitution method. I have an example on the projector screen for you, which we'll be starting off with. It says, solve the following pairs of simultaneous equations. And you have y is equal to half x, and 3y is equal to x minus 2. Now, of course, you might want to ask a question: how can you tell if this is a set of linear simultaneous equations or a pair of quadratic equations? It's linear because if you look at the power of the y here, it's 1. The power of the x there is also 1. The power of the y there is 1 as well. And the power of the x is also 1. So this is an example of a set of linear simultaneous equations. Now, the question now is, which of these algebraic methods do you use? Substitution method or elimination method? Now, you need to look out for the unknown x or y with a coefficient of 1. In equation 1, y has a coefficient of 1, which is what we look out for. X has got a coefficient of half, which we're not going to use because of the coefficient. In the second equation, y has got a coefficient of 3, which we're not going to use because the coefficient is greater than 1. And then x has also got a coefficient of 1. So the question now is, do you use the y in equation 1 or the x in equation 2? So, well, like I said, for you to use substitution method, you must look out for the variable with a coefficient of 1. And because both in equations 1 and 2, you can have a variable with a coefficient of 1, you can, of course, use substitution method. So let's see. Let's go over the steps involved when using the substitution method. Step 1. Like I said a moment ago, you look for a variable with a coefficient of 1, and then you make it the subject of the formula. We are going for equation 1 because already y has got a coefficient of 1, and at the same time, it's already the subject of the formula. If you look at equation 2, x has got a coefficient of 1, but it's not the subject of the formula. And so that's why we can't use equation 2. Rather, we'll use equation 1, where y, with a coefficient of 1, is already the subject of the formula. That takes us to step 2, where you now substitute the y from equation 1 in equation 2. So anywhere you see y in equation 2, it's now going to be replaced with half x, because from equation 1, y is equal to half x. So anywhere you see y in equation 2, that y will now be replaced with half x. So that takes us to step 3. So in equation 2, where you have 3y is equal to x minus 2, the y will now be replaced with half x. And then you have that being equal to x minus 2. And so when you now open the brackets and you cross multiply, when you open the brackets there and you cross multiply, you have 3x, and then the 2, which is the denominator on the left hand side, goes over to the right hand side, and then it multiplies all that you have on the right hand side. So you have 3x on the left hand side, and then that 2 times x minus 2 on the right hand side. And then when you expand that, you still have 3x on the left hand side, And then on the right hand side, 2 times x gives you 2x. 2 times 2 gives you 4. And then of course you don't forget the minus in between. Alright, so let's move on to the next step, slowly but surely. So now you collect like terms and then you solve for x. So far we now have just one unknown, which is x. So it's that x that we are going to solve for right now. So we collect like terms, and what happens is the 2x on the right hand side, you move to the left hand side, and when you do that, the sign changes. Watch. So you have 3x minus 2x gives you minus 4. And 3x minus 2x is simply x. So the value of x is minus 4. So there you go. Now we have a value for x. X is minus 4. So given this value of x, you now substitute in equation 1 to get the value of y. So now that we have the value of x, we put it in equation 1 to get the value of y. So anywhere you see x in equation 1, you replace with minus 4. Because now we have a value for x, which is minus 4. So that's equation 1, y is equal to half x, but the x is now replaced with the value of x, which is minus 4. And so when you simplify that, half times minus 4, the 2 goes in minus 4 to give minus 2. So your final answer, the value of y, is simply y is equal to minus 2. So there we go. But finally, do check your values of x and y by putting them in the given simultaneous equations, just to be absolutely sure that these are indeed the correct values of x and y. Right, students, so now that we have the values of x and y, x is minus 4 and y is minus 2. You need to check your values of x and y by putting them in the given simultaneous equations to be absolutely sure that these values are indeed correct. So, when x is minus 4, y is minus 2. Let's substitute values into equation 1. When x is minus 4, if you put minus 4 there, half of minus 4 gives you minus 2. Y is minus 2. So that is correct for equation 1. Now let's see if it's the same for equation 2. When x is minus 4, minus 4 minus 2 gives you minus 6 for the right hand side. And then y is minus 2. Minus 2 times 3 gives you minus 6. Minus 6 is equal to minus 6. So yes, indeed, these values of x and y are the solutions for this given pair of simultaneous equations. So that's that, and then that clearly shows you the steps we follow using the substitution method in solving a given set of simultaneous equations. The next question we'll look at how we continue using the substitution method. So let's see. If you're asked to solve the given pair of simultaneous equations, x plus y is equal to 3, and 2x squared plus y squared is equal to 54. Now, clearly you can see in equation 1, the coefficient of x is 1, the coefficient of y is also 1, the power of x is 1, the power of y is also 1, meaning equation 1 is a linear equation. But when you look at equation 2, the power of x here is 2, the power of y is also 2, meaning equation 2 is non-linear. As a matter of fact, equation 2 can be said to be quadratic. So this pair of simultaneous equations is a non-linear pair of simultaneous equations. So let's see, how do we solve the given pair of simultaneous equations? Now, like I said, we're using the algebraic method, and we have two possible methods: substitution method and the elimination method. And like I said, for you to use the substitution method, you have to look for the coefficient of the unknown, which is 1. In equation 1, the coefficient of x is 1, which is good. The coefficient of y is also 1, which is also good. So therefore, you can indeed use substitution method. So we'll go for substitution method in this question. So let's see the steps involved. So moving step by step, step 1, like you saw in the previous example, we will look for a variable where a coefficient of 1 and then make it the subject of the formula. Now the choice is yours. You can decide to make x the subject or y the subject, because both have a coefficient of 1. The choice is really yours. Just decide on one and then make it the subject of the formula. Well, I decided to make y the subject of the formula. So from equation 1, we make y the subject of the formula. And by so doing, you keep y on the left hand side, but you move x to the right hand side. And when you move x, the sign changes. It's positive sign here, but then when you move it to the right hand side, it changes to negative. And so you have y to be equal to 3 minus x. So we've changed equation 1 by making y the subject, giving us y is equal to 3 minus x. And so you substitute this expression for y, that is 3 minus x, into equation 2. So anywhere you see y in equation 2, you substitute the expression 3 minus x. And so in step 5, so equation 2 is 2x squared, which is the 2x squared there, that's the first term, and then plus. So y squared, the y squared, or I should say the y, will now be replaced with 3 minus x. So that y will be replaced with 3 minus x, and then with the square on the outside, that is equal to 54. So we are substituting 3 minus x for the y in equation 2. And the whole idea is for us to have just one unknown, x, and that way it's easier to solve. Okay, so you expand the bracket, so you have the 3 minus x all squared. You have to expand and open the brackets there. So when you open the brackets there, you have 2x squared. Now the 3 minus x all squared is the same as 3 minus x times 3 minus x. So we need to expand that. We need to open the brackets. And how do we do that? When you do that, you have the 2x squared, which is that. Now, you take the 3 to multiply that 3. 3 times 3, that's your 9. And then you take that 3 again to multiply the minus x. 3 times minus x gives you, well, of course, I've added that together here. So you have 9 minus 3x. And then you take the minus 3x here to multiply that. Minus x times 3 gives you minus 3x again. And then you take the minus x times minus x. That gives you plus x squared. And so when you collect like terms here, the minus 3x gives you the minus 6x. So that's how we arrive at the minus 6x. Okay, and so from there, you collect like terms. You've got the 2x squared here, and you've got x squared there. You bring them together, and you have just one term in x. You've got a 9. We'll move the 54 from the right hand side to the left hand side. And then again, remember, when you move it, the sign changes. Sign is positive, the 54 has a positive sign, and once you move it to the left hand side, the sign becomes negative. So you have minus 54. So you have your 2x squared plus x squared, we collected like terms now, minus 6x plus 9 minus 54. So we are collecting like terms such that you have the terms with the x squared first, and the term with the x next, and the constants, the last terms. Okay, so 2x squared plus x squared gives you, so there you go, we move the 54 to the left hand side. So 2x squared plus x squared gives 3x squared, then with the minus 6x, and plus 9 minus 3, plus 9, sorry, minus 54. That gives minus 45. So now you can see clearly we have a set of, actually you have a quadratic equation. You have a quadratic equation here, and we need to see how we can solve the quadratic equation to get the values of x. Now, because the quadratic equation here has got a power of x to be 2, it means the solution will give 2 values of x. Okay, so that's the next step. So you simplify by dividing through by the common factor of 3. Of course, you will notice that 3 can actually divide through the 3 terms. So you factorize by taking out the common factor. The common factor in this case is 3. You can divide the first term by 3, the middle term by 3, and the last term by 3. So 3 is common. So you divide through by 3. When you divide through by 3, 3x squared divided by 3 gives you x squared. 6x divided by 3 gives you 2x, and of course with the sign, so you have minus 2x, and then minus 45 divided by 3 gives you minus 15. So now you have this quadratic equation, which we're going to solve in the next slide. So next slide, continuing from where we left off. So we solve the quadratic equation using factorization method. So it's important for you to check that you can actually factorize this. So this is the equation we had earlier on. So it's important for you to check that you can actually factorize the given quadratic equation. But not to worry, if you cannot factorize, you should still be able to use the other methods of solving quadratic equations, be it the completing the square method or the quadratic formula. But thank goodness we can actually factorize this given quadratic equation. Okay? And when you try to factorize it, you will get this: x minus 5, x plus 3 is equal to 0. And from there, we'll get the 2 values of x we need. And so the 2 values of x are x is equal to minus 3 or x is equal to 5. Well, I can simply show you how we got these 2. Now from here, if x minus 5 is equal to 0, and then of course to get the value of x, you move the minus 5 to the right hand side. When you move it, the sign changes, and so you have x is equal to 5, which is this 5. And then when you take this as well, x plus 3 is equal to 0. Again, to get the value of x, you move the plus 3 to the right hand side. When you move it, the sign changes, it becomes minus. And so the value of x will be x is equal to negative 3, which is what we have here. And so these are the 2 values of x. Okay, so we now substitute these values of x into get the corresponding values of y. Remember we had this expression from earlier on, y is equal to 3 minus x. So to get the value of y, we'll substitute each of these values of x in there to get the corresponding value of y. So when x is minus 3, we'll get the value of y, and when x is 5, we get the corresponding value of y. So we do that next. So when x is minus 3, we'll now substitute these values of x into this expression to get the corresponding values of y. Okay, so when x is minus 3 is one of the 2 values of x we got earlier on. So we substitute this value of x in there to get the corresponding value of y. So when x is minus 2, so you have y will now be equal to 3 minus 3. Okay, so that is your value. So we're substituting, or I should say, replacing x right there with its value, which is the minus 3. So you have 3 minus 3. And of course you know, when you open the bracket, you have 3 minus 3. Now, minus times minus gives you plus. And so, value of y is 6. So when x is minus 3, y is 6. So next up, let's see the value of y when x is 5. So we do exactly the same. When x is 5, we replace x in this expression. Okay, let me put this in a box. We replace x in this expression with its value now, which is 5, to get the corresponding value of y. Okay, so when you do that, y will be equal to 3 minus 5. And 3 minus 5, of course, gives you minus 2. So these are the values we have. When x is minus 3, y is 6. When x is 5, y is minus 2. Okay, so finally, at this step is really, really important. You need to check the values of x and y by putting them in the given sandwich equation to be absolutely sure that they are indeed the correct values. So let's just check. When x is minus 3, if you put minus 3 there, minus 3, when x is minus 3, the corresponding value of y is 6. Minus 3 plus 6. Well, clearly that is 3. So that is correct for the first set of values. Now let's also try the second set of values. When x is 5, y is minus 2. When x is 5, when x is 5, y is minus 2. 5 minus 2 gives you 3. So these values of x and y are indeed the correct values. As you can see, we've just shown that they satisfy the first equation. Now let's do exactly the same for the second equation. When x is minus 3, now minus 3 squared, that's minus 3 times minus 3, that gives you 9. So you have 2 times 9 plus, when x is minus 3, the corresponding value of y is 6. So you have 6 squared. 6 squared is 36. So now you have 2 times 9, which is 18. 18 plus 36. 18 plus 36. Which is the 54 you have there. So that is correct for the first set of values. Now let's go to the second set of values. When x is 5, y is minus 2. When x is 5, 5 squared is 25. So you have 2 times 25 plus the corresponding value of y is minus 2. Minus 2 times minus 2 gives you plus 4. Okay, now 2 times 25 is 50 plus 4. And that gives you 54, which of course is what we have on the right hand side. So yes, indeed, these values are the correct values for the solution to this given pair of simultaneous equations. Okay, so as you can see clearly, we've shown, or we're able to show, how to use the substitution method in solving given pair of simultaneous equations. Now we'll move on to the third example. And it reads, if x plus 2y is equal to 0 and 4x minus 3y is equal to 11, find the value of x plus y. Aha. Now here you have to be very careful. You've got to be careful because in this question, once you get the values of x and y, you don't stop there. You go one step further to now find the value of x plus y. And that's why, students, it's important for you to be able to read the question very carefully and make sure that when you get a final answer, you cross-check and be absolutely sure that it answers the given question. And as you can see in this case, when you get the values of x and y, you don't stop there. For you to get your final answer, the question says find the value of x plus y. So once you've gotten the values of x and y, you don't stop there. You now need to add the values of x and y to get your final answer. Okay, so please take note of that. Always read the question carefully and make sure your answer confirms with the question. Alright? Let's start. We need to write these equations out clearly in the way we all are familiar with. Okay? Now, of course, when you look at this, this is the first equation, this is the second equation. Again, the power of x here is 1, the power of y there is 1, so that makes it linear. The power of x there is 1, the power of y there is 1, which makes it also linear. So again, we're dealing with a pair of linear simultaneous equations here. And the good thing here is also, when you look at the coefficient of x here, it's 1, meaning straight away, once you can identify a variable with a coefficient of 1, that tells you instantly that you can use the substitution method. So without wasting any time, you might as well just go for the substitution method in this case. So we don't need elimination method just now. I'm going to show you examples where the elimination method is applicable. But in this case, we are concentrating on how we use the substitution method. Alright, so let's follow the steps, the usual steps we follow. Step 1. Remember step 1. Okay, right, so you write the equations out very clearly. Look at equation 1, x plus 2y is equal to 0. That's equation 1. And then of course, 4x minus 3y is equal to 11. That's equation 2. So once you've written out the two equations clearly, you can then go step by step. So step 1, you look for a variable with a coefficient of 1 and then you make it the subject of the formula. So x has a coefficient of 1, so we make x the subject of the formula from equation 1. And how do you do that? So easy, it's so easy. Okay, so from 1 you make x the subject formula, and to do that you simply move the 2y to the right hand side. And remember, like I said, when you move that, the sign changes. The sign here is plus, so when you move it, it becomes minus. So x will be equal to 0 minus 2y. And because 0 means nothing, so x is simply equal to minus 2y. Okay? So from here, on, we will substitute this x in equation 2. So anywhere you see x in equation 2, you replace the x with minus 2y. Okay, so let's see. We have 4x, so the x now becomes minus 2y. And then minus 3y is equal to 11. And so from here, you open the brackets, collect like terms, and then you simplify. Okay? So you open the brackets and simplify. When you open the brackets, 4 times minus 2y gives minus 8y. And then minus 3y is equal to 11. And of course, minus 8y minus 3y gives minus 11y. Okay? And if minus 11y is equal to 11, to get y, you simply divide both sides by minus 11. Divide both sides by minus 11, you end up with the value of y as minus 1. What do I mean? For those of you who can't see that clearly, you want to find y, so you divide both sides by minus 11, which is the coefficient of the y. Divide both sides by minus 11. So this minus 11 will cancel with that, and you're left with 1, which is your y. 1 times y gives you y. Okay? There's a 1 there, but we don't normally put it. I'm sure you know that. And that's equal to, well, of course, 11 divided by minus 11 gives you minus 1. Minus 1. I'm going to write that clearly so you can see. So there you go. Y is minus 1. So there you go. We have the value of y, which is minus 1. So with this value of y, we can substitute back into the given equation to get the corresponding value of x. Right, now, here's the reason why I put a box here. Because from here, to get the value of x, all you need to do is just to put the value of y there, and you can just straight away see what your value of x is. So you substitute this value of y to get the value, or I should say, you substitute the value of y to get the value of x, I meant to say here, to get the value of x. Okay, x is what we're looking for. We already have the value of y, so you put this value of y here to get x. So this should be x. Now when you do that, so x will be minus 2, y. The y will be replaced with the minus 1, which is the value we've just had for y. So x will be minus 2 times minus 1. Minus 2 times minus 1. Remember, minus times minus gives you plus. Remember the golden rule. For those of you who by now can't remember, minus times minus gives you plus. Plus times plus. Plus. So when the sign is the same, you get a plus. When the sign is the same, you get a plus. But when the signs are different, minus times plus or plus times minus, you get a minus. So this is the golden rule when it comes to signs. So minus times minus, the signs are the same. When the signs are the same, you get a plus. So you have x to equal to plus 2. So you have the value of x to be equal to, so from here, okay, I think I actually have it written down. The slides just came out, yeah, that's right. So x is equal to 2. But like I said, you don't stop there. Once you have the values of x and y, you don't stop there, because the question says find the value of x plus y. So be careful. If you get to this point, you're not completely done. You still have one vital step, okay, based on the question. The question says find the value of x plus y. So get the value of x plus y. Now we have the value of x, which is 2, and the value of y, which is minus 2. So x plus y will simply be x2 plus y, which is minus 1. Okay, so plus times minus, remember from our golden rule again, plus times minus gives you minus. So you have 2 minus 1. And 2 minus 1 is simply 1. Okay. Right, students, so this brings us to the end of today's lesson on solving simultaneous equations using substitution method. Now, I will give you a set of questions for you to try at home or wherever you are, and then I'll put the questions on the school portal. Now, try your questions, try your hands, I should say, on those questions, and if you have any problems whatsoever, the next class we'll be having, I will treat your questions, and if you want us to interact further and entertain more questions, I will do just that. But like I said, I will post questions on this. I want you to try your hands on those questions, and I would appreciate if you can drop me an inbox with the solutions to the questions, your solutions to the question. I will go through, and if I need to get back to you, I will. And then if I need to explain to the whole class during the next lesson, I'll do just that. Okay, thank you very much for your time. I shall see you again next time.